So we're going to get started with long division, and let's just remind ourselves how the long division algorithm works. So we want to divide 187 by 3 using long division. So we're going to set this up. We put our 3, we do our division symbol, and we put our 187 in here. And we ask ourselves, well, how many times does 3 go into 1? It doesn't. How many times does 3 go into 18? It goes in 6 times. So 6 times 3 is 18. And then after we do that, we subtract, and 18 minus 18 is 0. Then we bring down the next digit, and we rinse and repeat, right? So then how many times does 3 go into 7? 2. 2 times 3 is 6. Once again, we subtract 1, and 3 no longer goes into 1, so we say we have a remainder of 1. And we could write this out as we would have 187 over 3 is the same as its whole part, which is 62, plus its remainder over its divisor. So we would then say, well, 187 over 3 is the same as 62 and a third, right? Or 187 over 3, a reasonable approximation would be it's about 62, right? Because that's its whole part, disregarding the remainder, assuming it's going to be small. Well, that's going to be a theme we're going to continue. So when we are doing long division for polynomials, we are actually going to follow exactly that same algorithm. There are a few gotchas we have to be careful about when we do this, but for the most part, everything is going to work the same way. So we want to now do division, but this time we want to divide 2x cubed minus 3x squared plus 4x plus 5 by x plus 2. So we set up our division in the same way. So x plus 2, we make our long division bar. So 2x cubed minus 3x squared plus 4x plus 5. And just like what we did up here, we need to figure out how many times does our divisor go in. So we're going to focus on our first part of this binomial. So we have x. And we want to ask ourselves the question, how many times does x go into 2x cubed? Or in other words, what is 2x cubed divided by x? So we could write it out, and that actually makes it a little bit easier to see. Well, what is 2x cubed divided by x? Well, if we divide two things with the same base, we subtract their exponents. So we would get 2x squared. Long division with polynomials is often easier if we ask ourselves the associated multiplication problem. So the better way to think about this is, well, what times x gives 2x cubed, right? Well, what would I need to multiply x by to get 2x cubed? Oh, 2x squared, which is exactly the number we're going to need. So we put that here in our division. So then after we got our 6 up here, what did we do? We did 6 times 3, and we wrote it beneath, and we subtracted. So we're going to do the same thing. We're going to go 2x squared times x, which will be 2x cubed, and that was always our goal. But then we had a binomial, so I have to do 2x squared times 2, which gives me positive 4x squared. But then I have to remember to subtract. So one of the first gotchas that we have to be careful with is we're subtracting that whole binomial. So if it helps you visualize it, put it in parentheses, because we're taking away both terms, not just the first term. And in fact, the first term should always subtract out to 0 or reduce out completely. And then we have negative 3x take away a positive 4x. So negative 3x squared minus 4x squared is negative 7x squared. So after we got our number here, we always just brought down the next thing and we rinse and repeat. So in this case, we bring down a 4x and we start the process all over. So now, what times negative 7x, or what times x gives me negative 7x squared? Well, that's going to be negative 7x. So negative 7x times x is negative 7x squared, and negative 7x times 2 is negative 14x. And then we have to remember that we are going to subtract this whole group. So once again, our first thing is going to reduce out because we have minus a minus 2x squared, so that's the same as addition. But here we have to be extra careful because we have minus a minus again, and since we're subtracting, there's going to be a lot of minus signs, so minus minus is going to give us a plus. So 4x plus 14x is going to give us positive 18x. So just be careful when we're doing this, because there can be a lot of minus signs, and that is the most common error that we'll run into, is we'll lose a minus sign somewhere in this process. All right, we're now to our penultimate step. All right, so now we ask ourselves the question, what times x gives us 18x? Well, that's going to be 18. So we get plus 18. So 18x. And then 18 times 2 is positive 36. We subtract, those reduce out, and 5 take away 36 gives us negative 31. And now x no longer goes into 31, just like up here, 3 no longer went into 1. So we then have our remainder of negative 31. So then this tells us, writing it out in a similar fashion to what we had above, 2x cubed minus 3x squared plus 4x plus 5 divided by x plus 2 is equal to our whole part, which is 2x squared minus 7x plus 18, plus our remainder, which is negative 31, over our divisor, which was x plus 2. So similar to what we did up here, when we had 187 over 3 was our whole part plus our remainder over our divisor, when we do polynomial long division, we're going to get the same thing. This is our whole part. The numerator is our remainder. And the denominator is going to be the divisor. All right. Let's take a look at our next example. But before we do, if we set up the division problem or if we had 154 divided by 7, and we did long division, so 7 goes into 154. 7 goes into 15 twice. 2 times 7 is 14. We subtract, we have 1. We bring down our 4 to get 14. 7 goes into 14 twice. 14 this time we ended up with 0, so we had a remainder of 0. What does that tell us about 7 and 154? Well, specifically, what's its associated multiplication problem? Well, this tells us that 7 times 22 is equal to 154. And we note that the divisor is a factor, right? So that gives us a factorization. We might be able to factor some of those things further, but if something divides and has a remainder of 0, that means that it is a factor of the original number. Well, let's see what happens when we do this long division. So we set up our long division. So we have x plus 1, and it divides into 5x squared plus 3x minus 2. So what times x is going to give us 5x squared? Well, that's going to be 5x. So 5x times x is 5x squared. 5x times 1 is 5x. And we subtract. Those things reduce out. 3x minus 5x gives us negative 2x. And we bring down our negative 2. And then we ask ourselves, well, what times x gives us negative 2x? And that's going to be negative 2. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. We subtract. And our first term reduces out as we would expect. But then the minus 2 gives us a positive 2, and negative 2 plus 2 is 0. So this goes in and has a remainder of 0. So then if we were to write this out, what it tells us is the following, that our division, 5x squared plus 3x minus 2 over x plus 1 is equal to our whole part, which is 5x minus 2, plus our remainder over our divisor. But our remainder is 0. So adding 0 doesn't change anything. Well, if I multiply both sides by x plus 1, then I would get 5x squared plus 3x minus 2 is equal to 5x minus 2 times x plus 1. This factored that polynomial. In fact, to factor polynomials of degree greater than or equal to 3, this is the general method for factorization. We find the zeros, and we have to do division. There are a couple of formulas for special forms in third-degree polynomials, but after third-degree polynomials, there's really not formulas anymore. There's a couple of special cases that we can do some algebra on, but for the most part, we have to use another theorem called the rational roots theorem to help us find what are possible zeros, and then just do long division until we find them. All right. So it is now your turn. But when doing polynomial all monomials of degree less than the polynomial must be represented. If a polynomial is missing any terms, they must be filled in by 0 times x to the n. So when we take a look at your U-try that you're going to be working on, when we look at the polynomial in the numerator, so right here, this is missing the linear term. So it's degree 2, but it only has a degree 2 monomial and a constant, so a degree 0 monomial. So we rewrite x squared minus 1 as x squared plus 0 times x plus 1. So we're missing this linear term here, and we fill it in, and we didn't change anything when we did this because 0 times anything is 0, and when you add 0 to something, it doesn't change it. I had a typo there. It should be minus 1. So we rewrite x squared minus 1 as x squared plus 0x minus 1, and that is what we're going to use to set up our long division. So if we don't include that term when we do our long division, the algorithm will crash, and what I mean by that is when you move to one of the next steps, your like terms won't line up anymore, and it just makes the algorithm not pretty. All right, so we start by asking ourselves, well, what times x is going to give us x squared? And that's just x. So x times x is x squared, and x times 1 is x. We then subtract. Our lead terms reduce out as they should, and then I have 0x minus a positive x, so that gives me negative x, and I bring down my next term. So what times x is going to give me negative x? Well, that's negative 1. So negative 1 times x is negative x, and negative 1 times 1 is negative 1. And then I subtract, and I get all those minuses, so minus minus becomes a plus. These terms reduce out, and negative 1 plus 1 is also 0, so I get a remainder of 0. So that tells me that x plus 1 divides in evenly. And we actually knew that, right? That x squared minus 1 over x plus 1 is equal to x minus 1. So it's worth noting in this case that we know how to factor x minus 1, and it factors as x minus 1 over x plus 1, all over x plus 1. And those reduce out, leaving us with the same answer, right? So when things factor the way that we've learned in the past and reduce, we'll get the same thing as if we do the division algorithm. But as we know, not all polynomials will factor. So the division algorithm is more general than factoring, right? So in the cases where things do factor, we will always get the same answer as we did in this case, right? Because if you factor x squared minus 1, you get x minus 1 times x plus 1. The x plus 1s reduce out, and we're left with x minus 1, which is the same thing. All right. So let's take a look at example number 4. So this time we have a degree 3 polynomial divided by a degree 1, or a linear. So a cubic over a linear. And each step might be a little bit more complicated, but the algorithm works in pretty much exactly the same way. So we take our divisor, 3x plus 2, and we're going to divide it into 6x cubed plus 11x squared minus 31x plus 1. All right, so now we have to ask ourselves the question, what times 3x gives us 6x cubed? Well, to get 6, we would have to multiply 3 by 2. And to get from x to x cubed, we'd have to multiply by x squared. So we're going to have 2x squared. So then 2x squared times 3x gives me 6x cubed. And 2x squared times 2 gives me positive 4x squared. And we subtract. Those reduce out. 11x squared take away 4x squared is 7x squared. and we bring down our next piece. All right, and now we have to ask ourselves, well, what times 3x gives us 7x? Well, it's going to be, or 7x squared, it's going to be 7 over 3 times x. Because if we multiply by the fraction 7/3, the 3 and the 3 in the denominator will reduce out, and what's the only thing that will be left behind? 7. So then that's going to give us 7/3 x times 3x gives us 7x squared, and 7/3 x times 2 is going to give us 14/3 x. And then we have to subtract. All right, so we know those are going to reduce out, but let's be a little careful here, because with me, I always make some silly arithmetic mistake. So we're going to have negative 31, and we wish to take away from it 14 over 3. And that gives us negative 107 over 3. And we bring down our 1. And then we rinse and repeat. So what times 3x is going to give us negative 107 over 3. So think of it this way, 3y, so 3 times what equals negative 107 over 3. So we'd have to divide both sides by 3. And if you don't remember what that is, we divide both sides by 3 on our calculator, and we get negative 107 over 9. So negative 107 over 9, and that's going to give us negative 107 over 3x, and then negative 107 over 9 times 2, so we multiply that by 2, and we get negative 214 over 9, so negative 214 over 9, and then we subtract, but be very careful with all those minus signs, right? So then we have 1 plus 214 over 9. So 1 plus 214 over 9 gives us 223 over 9. And that's going to be our remainder, right? And the reason I chose to use fractions here is you will cause yourself all sorts of grief if you start using decimals, because things that get divided by 3 give repeating decimals like 0.33333 or 0.666666, right? And then you're going to have to start rounding off. And the minute you start rounding, your answer is wrong. So we have to use fractions. Decimal approximations will lead to rounding error that will get you the wrong answer 100% of the time. All right. So turns out there is another way we can do division called synthetic division. Synthetic division turns out to be a bit easier to execute, but it is also slightly limited on what we can do. So when we're trying to do synthetic division, the first thing we have to be aware of is we can only use it if the divisor is a degree 1 with the x coefficient is 1. So we have to note here the coefficient on x must be 1. So when we say it has to have this form, it has to be linear, and moreover, the slope has to be 1. So the coefficient on the x has to be 1. So then To do synthetic division, when we have it this form, we will note too that the k we are going to use in the algorithm is actually the opposite of the number that is present. So our formula has a minus sign in it, x minus k. We need the number k. So in practice, we are going to have to take the opposite of whatever that digit is, right? Step B says write the coefficients of the dividend. 3, we're going to bring the lead coefficient down. 4, we're going to multiply the lead coefficient by k and write the product in the next column. Add the terms of the next column. Multiply the result by k, write the product in the next column. Repeat 5 and 6, or f, or e and f in this case, until the algorithm terminates. So I know that's super clear, so let's actually just do an example to illustrate what we are talking about. So let's go ahead and do example number 5. So the very first thing we want to do is we have to identify our k. So we look at our divisor. So our divisor is x plus 1, and we want to compare that to x minus k. So this tells us that negative k is equal to positive 1. So then to solve for k, we get k is negative 1. So what I was saying is whatever our coefficient is that we're adding to x, it's always going to be the opposite. So in this case, we had a positive 1, so our k was negative 1. So we place our divisor in a little half square that looks something like this. We're going to complete our first column by adding only the coefficients from this. So we have 5, 3, and negative 2. We'll then put our line here. So what the first step says is we bring the lead coefficient down. So the 5 just comes all the way down here. We then take our 5 and we multiply it by our k. So 5 times negative 1 is negative 5, and we place that in the next column, and then we add. So 3 plus negative 5 is negative 2. And then we rinse and repeat. Negative 2 times negative 1 is positive 2, and negative 2 plus 2 is 0. So now, step H says use the bottom row of numbers to write the quotient. The number in the last column is the remainder. So then this is our constant, and then this one is going to be degree 1. So it starts at our remainder, and then it goes, as we move to the left in these columns, it counts up. Or in other words, we could count down from starting here. We started with a degree 2. If we divide by a degree 1, then the first thing is going to be degree 1, degree 0, and our remainder. So then this is the polynomial 5x minus 2, remainder 0. So let's go back and take a look. This was actually example 3, right? Where we did the long division. We did the long division, and what did we get? 5x minus 2. And when we did the long division here, what did we get? 5x minus 2. So synthetic division seems a little different, but we'll notice a few things when we compare and contrast this with the division algorithm. So when we do the traditional division algorithm, after each time we multiply, what did we do? We subtracted. In synthetic division, we added. Well, why is that the case? Well, instead of using k, what did we use? The negative of k. So instead of subtracting, we now get to add. Generally, less issues occur with addition. So the reason we add when we do this, as we said, is we reverse the value of k. The only thing we really need to be careful with is, remember, the divisor has to be a linear function with degree 1. So degree 1, and its lead coefficient also has to be 1. This algorithm will fail if the coefficient on the x is anything else but 1. So it's definitely easier to use, but we have to be a little bit more careful when we do this and make sure that we're using it only on things that make sense for it to be used on. All right, so we identify our k values. So we have x minus k, and minus k is positive 2. So that tells us k is negative 2. And we put our coefficients 4, 10, negative 6, and negative 20. We bring our 4 down. 4 times negative 2 is negative 8. And we add, and we get 2. 2 times negative 2 is negative 4. So negative 6 plus negative 4 is negative 10. 10 times negative 2 is positive 20. So we get 0. So that's our remainder. So we get 4x cubed plus 10x squared minus 6x take away 20, all divided by x plus 2 is equal to 4x squared plus 10x, oh, I'm looking at the wrong line, just kidding, 4x squared plus 2x take away 10. So our coefficients are these values right here. And then plus our remainder over our divisor, and our remainder this time was 0. So we didn't really have to include it over our divisor, which was x plus 2. So notice synthetic division is just a lot cleaner, right? So they basically took the division algorithm, got rid of all the variable parts of it, changed it so we no longer had to use subtraction, and now we're only dealing with the numbers, and then we just fill back in the missing variables at the end. It makes the process a lot cleaner and simpler to work with. It also makes automation a lot easier if you're trying to use something like a spreadsheet or something else to do these types of computations. All right. So now let's take a look at our last example for this section. So the volume of a rectangular solid is given by V equals 3x to the fourth plus 3x cubed, or minus 3x cubed, minus 33x squared plus 54x. If its length is 3x, then its width is x minus 2. Find the height. So the first thing we need to remember is the volume of a rectangular solid and when we say rectangular solid, what we really are talking about is a box, is given by the formula V is equal to its length times its width times its height. We are told the following. Well, our volume is going to be this polynomial. So we have 3x to the fourth minus 3x cubed minus 33x squared plus 54x is equal to the length, so that gives us 3x times its width, which is x minus 2 times its height. So we need to solve this equation for h, right? So we can divide both sides by 3x and x minus 2, and we divide by 3x and x minus 2. So that gives us our h that we're looking for. But now we may wish to factor this a little bit and see if we can reduce. So in 3x to the fourth minus 3x cubed minus 33x squared plus 54x, we'll notice immediately that we have a greatest common factor of 3x. So we factor out our GCF, so 3x, and that's going to leave behind x cubed minus x minus minus x squared minus 11x, and 3 goes into 54 18 times, all over our 3x and our x minus 2. So those are going to reduce out. If you really wanted to, you can do long division with 3x, and that whole thing you will get the same answer as we talked about earlier, but it's a giant waste of time to do long division with monomials when you can just factor and reduce them out most of the time. But this part we will have to do long division. So we're going to use long division on the x minus 2 and the rest of it. So now we need to divide x minus 2 into this. Well, I say long division or synthetic. And in this case, synthetic is going to be a lot easier. So we have x minus 2, so we're going to get our k is going to be positive 2. And we set up our coefficients, 1, negative 1, negative 11, and 18. So we bring down the 1. 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 2 is still 2. Negative 11 plus 2 is negative 9. Negative 9 times 2 is negative 18. We add and we get 0. So this tells us that x cubed minus x squared minus 11x plus 18 all over x minus 2 is equal to x squared minus x minus 9. Oh, sorry, plus. That is a positive one. So x squared plus x minus 9. So finally, that is the height. So the height is x squared plus x take away 9. And you did not have to use synthetic division. If you used long division, you will get exactly the same answer in the end. So when you can use synthetic division, you will always get the same answer as if you did long division.